we going to the next paper. And the title of next paper is Feature Extraction for Product Advertising Reviews in Identification in Social Media. And the presenter is Yu Chen Ku, and he's from National Taipei University of Technology. So let's welcome for his presentation.
Good evening, everyone. My name is Yu Chen Ku. I come from National Taipei University of Technology. I represent my professor, Jun Hao Wang, to give the presentation today. The topic of my presentation today is feature extraction for product advertising reviews, identification in social media. This is the outline of my presentation. We are going to go over introduction, related work, the proposed method, experiments, and discussions, and finally conclusions. First, introduction. Research. With the popularity of social media, research shows that 87% of people tend to seek user opinions or comments from users who already use the product before making purchasing decision. Thus, the social web has become an important venue for marketing in business. Many vendors notice they can make lots of money from social media, so they offer bloggers the promotional products and even pay them to write product using experiences in various social media. We call this advertising review or ad reviews, since they are different from non-advertising comments, which show real user experiences and opinions. The goal of this paper is to investigate effective features for identifying ad reviews. However, the major challenge of identifying ad reviews is that the truthfulness of review is hard to judge. According to our observations, the potential features might come from different sources: document content, document statistics, and also social responses to the review. After extracting potential features, we train an SVN classifier for ad review identification. In our experiment, we collected more than 2,000 reviews from popular blogs, and our method can perform over 90% in accuracy. The experiment on about 16,000 cosmetics forum reviews showed a good accuracy about 87%. Our method outperforms conventional text classifier using TF-IDF with much higher efficiency. Next, we are going to talk about redacted work. Generally, there are three different ways to do review spam detection. For text-based method, review text contents are utilized as the main features with other possible clues, such as sentiments of terms and product mentions. For behavior-based methods, User-ready behaviors can be used to find out anomalies in user behaviors. For network-based methods, connectivity structured among reviews, reviewers, and products are modeled in graphs. Recent trend in common or review spam detection is to combine different types of features. For example, content, sentiment, product, and metadata of a review are among the most common features. In this paper, we explore the characteristics of social media and try to explore the effectiveness of content, statistics, and social-based features for identifying ad reviews. Next, we are going to introduce our proposed method. The overall architecture of the proposed method is in this figure. There are 3 parts. This is the first part of our method. First, we utilize our crawler to collect product-related reviews for a given product from web pages and blogs. And we break each sentence into its component words by word segmentation tool. Then we do stop word removal and extract punctuation marks from titles and reviews. Finally, we remove numbers. Next step is feature extraction. In this step, we extract 3 types of features from web pages and blog postings: content, statistical, and social features. According to our observations, product information is usually provided as a reference for writers. Therefore, we assume that the content similarity between product information and reviews could possibly be used as a potential feature. In this study, product information was collected from your customer, an online discussion forum on cosmetics with lots of product information from various vendors. Then we apply the TF-IDF rating for both reviews and product information and calculate the cosine similarity between them. Also, some vendors ask writers to include product-specific keywords in the corresponding title. Thus, we include the similarity between review title and product introduction title as another potential feature. Since titles are very short, we calculate the syntax value between them. The second type of features is statistical features. In addition to review contents, some potential statistical characteristics in documents could help us to identify ad reviews. Published dates of postings might be possible features, since vendors usually require the reviews to be published within a specific range of dates around the product launch period. And the third type of features is social features. In social media, users can give responses to a document by browsing, replying, or giving a like. Thus, these features can reflect the popularity of the document. As for the sentiment orientation, promotional text in ad reviews usually emphasize on the positive aspects of the product, while deliberately ignoring the negative ones. This shows that the number of positive opinion terms could outweigh negative terms. Another possible feature is domain-specific praise words. In different topic domains, people tend to use different words to praise and promote the benefits. After all 3 types of features have been extracted, next step is to make classifications. There are different types of classifier to be used for text classification. Since we focus on finding the most appropriate features, we simply use the well-known SVN as our classifier with type SVN. All classifications are done by using full-form cross-validation. Next topic, we are going to show our experiments and discussions. We first selected 90 campaigns in cosmetics category. Then, by using brand names and product names to search in popular blogs, we collected nearly 2,000 reviews in total. Among these reviews, about 1,000 are advertising reviews. The remaining ones are non-ad reviews. We further collected more than 1,000 blog posts as our data set of ordinary articles. Since general articles don't contain any product information, some features are not used here. As shown in this table, the best single feature can be obtained by press ratio, and we found that the overall accuracy and F major are about 93% when using all features. It shows the effectiveness of press ratios in distinguishing between ad reviews and ordinary articles. The best combination is press ratio, image count, and likes count, with accuracy and F major over 94%. And we compare our method to TF-IDF. Although the accuracy of our method is slightly lower than TF-IDF, the average training time and testing time of our proposed method are much more efficient. In the second experiment, we further check the performance of our method in the same domain of cosmetics. As shown in this table, the best single feature can be obtained by content punctuation and publish date. And we found that the overall accuracy and F major are about 80% when using all features. This validates our claim that punctuation marks help to distinguish from ordinary comments. And the best accuracy and F major more than 80% can be achieved when combining these features. Also, we compare our method to TF-IDF. Our method achieved a comparable effectiveness, which is only slightly lower than TF-IDF, but with a much higher efficiency. To further verify the classification effects from different data sources, we collected articles from your customer. In total, we collected more than 1,000 product information with about 3,700 ad reviews and over 12,000 non-ad comments. Since titles are not required in your customer, title-related features were not used here. As shown in this table, the best accuracy and F major are obtained by published date. The value of published date, link count, reply count, negative ratio are high in F major. This shows the feasibility of incorporating social features and identifying ad reviews in forums. The best accuracy, about 87%, can be achieved when combining all available features. The accuracy of our method is much higher than TF-IDF, and our method outperforms TF-IDF with much higher efficiency. This validates that distinguishing ad versus non-ad is not easy when using content alone. And there will be 5 discussions here. Discussion 1. In blogs and forums, the effects of publish date in identifying ad reviews are good. This might be related to the data characteristics, since product trial-related marketing campaigns are usually held during a specific period of time that is close to the launch date of a new product. And discussion 2. In table 1, press ratio is the most effective feature, but the effects of positive ratio and negative ratio are not as expected. This might be due to the inaccuracy of opinion lexicon for sentiment analysis, since the positive and negative terms used in comments are usually high depend on the domain, on the topic domain. Domain-specific lexicon might be needed here. Discussion 3. In the red part, the effect of punctuation marks, especially content punctuation, are good in blogs, but not as good in forums. This might be due to the more formal styles in blogs than in discussion forums. And in the blue one, the effect of content length and image count are better in blogs than in forums. This is due to the more diverse content in blogs with rich content and longer texts. And discussion 4. Social features are not as effective in blogs as in forums. This is reasonable, since most blogs are usually not created for the purpose of interaction, but only for personal writing. However, discussion forums are created to interact. These features reflect the interactive characteristics of online forums. And discussion 5. Link count is only effective when URL links are required to be put in blocks. And from the above observations, we can see our proposed features in identifying ad reviews from either general articles or non-ad comments in blogs and forums are both effective and efficient. This validates the practical use of our proposed method when review contents are more diverse and difficult to judge simply by content similarity. And finally, we are going to have some conclusions. In this paper, we have investigated potential features for identifying ad reviews by using content, statistical, and user and social features for classifying reviews with SVN. It's possible to achieve accuracy nearly 95% with data in blogs and accuracy about 87% with data in forums. And the performance is better than TF-IDF term weighting with much higher efficiency. And it shows the potential of our proposed method in real applications. Further investigation is needed to evaluate the performance in other topic domains. And this is the end of my presentation today. Thanks for your listening.
Any question? Actually, this is very interesting research, and I have some questions, but not very difficult question. Okay, the first one is I'm thinking about, do you do any weighting for social features? For example, maybe like, reply, and maybe reply is more important than like. Do you do any weighting?
No, they are equal.
They're equal.
Yes.
Okay, right. So maybe in future you can take this into account. Maybe.
Yes.
Yeah, maybe sometimes if you found an advertising reviews, maybe they use reply more frequently than like. Maybe I don't know.
Yes.
And yeah. And the second question is about link count. What is link count actually?
In articles, we usually write, maybe include some links in our article to show that if you want to know more about this topic or something, you can click the link to get the further information.
So in your conclusion is if we found more link count, so it means this more like advertising. All right.
Yes.
Thank you. Yeah. Any more questions? No. Okay. Thank you very much.
Okay, thank you.
And I just want to make sure is there any other presenter here? No. Okay. If no, I want to plan the end of this section, and I want to let you know this evening from 6 o'clock we have a reception on the first floor. It's a buffet style, all you can eat. So welcome everybody to join us this evening. All right. Thank you so much. See you.